Hello. In this video, I'd like to show you how Ageos, EnergyLab, and Seed can help you optimize power on your next i.MX8 ULP project. EnergyLab lets you accurately estimate power of the complete device and application through detailed simulation of your use cases. EnergyLab and Seed also let you optimize runtime power, where typical savings of 30 to 50% over the standard BSP can be achieved without the need for deep diving into the complexities of the hardware. I will now present a demo of our EnergyLab LITE and EnergyLab Pro products. Here we have EnergyLab LITE with a description of the 8 ULP EVK loaded. The description includes all power-related details of the hardware and also covers the power-relevant aspects of the software. With EnergyLab, users can easily add their own software tasks in order to cover their specific application. Now let's start the simulation. The use case we choose here represents a generic IoT edge device with a periodic network heartbeat and occasional data processing activity. Our scenario is shown on the left here. We can single step through the events and see power details update on the right with each step. Or we can just let the simulation run to the end. Now we can see power details on the right, including a breakdown of the top consumers, software tasks, as well as additional details that we want to track. Now, in order to explore alternatives, we will save this graph as a baseline, and now whatever change we make in the scenario will be reflected accordingly. Now we will comment out the MCU background task in order to see what would happen if we didn't run the M33 in the background at all times. So now let's save this and restart the simulation. And now when we step through the scenario, we'll see how much we're saving in each state. And then if we run this to the end, we can also see the total energy savings for our use case. Now once we have our software stack ready to run on the EVK board, we can use EnergyLab's test and measure window to connect to the board and see the actual power consumption. Now I have an 8 ULP EVK board on my desk, so let's connect to it and power it on. We can see Linux booting. The terminal windows on the bottom show us Linux prints on the left and M33 running Seed on the right. We have power consumption shown at the top in graph form as well as in table form up here on the right. And then we also have the Seed monitor, which shows us the state of key components of the 8 ULP. So let's log in and start the demo. As soon as the application starts, let me switch over to the SoC domain so we only see the voltage rails of the 8 ULP SoC. So as soon as the demo starts, we are in a low power state around 200 microwatts and occasionally wake up for a network heartbeat check. And then every now and then it will wake up and run some processing on the A35s. And when that's done, it will go back into the low power state and occasional network heartbeat checking. Now, if you want to apply this to your own application and customize it for your own board, Ageos also offers EnergyLab Pro. On top of unlimited modeling and simulation of hardware and software, EnergyLab Pro includes the Seed generator. Seed lets you configure and generate custom power management firmware optimized for your application and use case. Seed gives you fine-grained control of all power management knobs and dials, and it lets you choose and customize the power modes you need for your application. Now we just need to generate the firmware and include it in our boot image. Thank you for watching.